All right, good morning. We're going to go ahead and look at finding the roots of factored polynomials. This is D4, I believe, and we're basically going to talk about the vocabulary. So you have a factor theorem. It's important that you talk about polynomials and the zeros and the roots. So say you have, let's just say we have a P of X. So we're going to say that P of X is a polynomial. And then we're going to say that there's a real number C. So P of X is a polynomial with a real number C, and we're going to say that P of C equals 0. And so basically you can say then you can say that C is a 0 or a root of P of X. So basically you're saying that if you have some binomial, so say I have X minus C, which is a binomial, it is a linear factor. So it's a linear factor of the polynomial P of X. If and only if C is a 0. So that's going to be your factor theorem. Okay, so then we're going to talk about roots. So when I say that I want something in roots solution, you're going to also get this on worksheet 5.5, which is basically like a mini review. There's no video for that. So we're basically going to say that if you have the root solution, you're going to say that you have, let's just say P of X equals X squared plus X minus 2. And then you're going to find the factors, which we already know what they are, which are going to be X minus 2, X plus 2, X minus 1, and we're saying that those are equal to 0. And then you have what you call the roots, which is what we're looking for at this point, because we're trying to define the roots. You're going to say that when X plus 2 equals 0 and 0 equals X minus 1, I'm going to say that X equals negative 2 and X equals 1. So those are going to be my roots. And then when you talk about zeros, you're going to say that you have an intercept, negative 2 comma 0 and 1 comma 0. So that is a factor. Those are roots. And then these are zeros. So factors, roots, and zeros. Okay, so we're trying to find the roots. So we're going to suppose f of x equals 0. So 0 equals x minus 4, x plus 3. We're going to split each linear factor. So 0 equals x minus 4, 0 equals x plus 3. Now we're going to solve for x plus 4, x equals 4, minus 3, x equals negative 3. Then we have to present this together. X equals negative 3 comma 4. And it's or 4. Okay. Example 2. Find the roots of the factor polynomial. So it says x minus 1 multiplied by x plus 5 squared equals f of x. So we're going to suppose f of x equals 0. So x minus 1, x plus 5 squared equals 0. X minus 1 equals 0. X plus 5 squared equals 0. Plus 1, x equals 1. X plus 5 squared equals 0. We need to take the square root. It's just a step we need to take. So we're going to say x plus 5 equals 0. Minus 5 minus 5. X equals minus 5. We're finding the roots again. We want the roots. X. It's an x. Equals negative 5, 1. Okay, so let's look at section A, example 8. Find the zeros of a function when f of x equals 0, f of x equals x minus 6, x minus 9. So when we're looking at an equation, you're going to have x and f of x. So basically you're saying that f of x is y and it's also 0. So when we're looking for zeros, we're going to look for an ordered pair. And that's going to be our solution. So let's go ahead and set this up. 0 equals x minus 6. 0 equals x minus 9. It doesn't matter if it's in or outside, inside the parentheses or without the parentheses. So plus 6, x equals 6. Plus 9, x equals 9. We're not done. We said that f of x equals 0, which is also equal to y. So this right here is y. So let's go ahead and make our ordered pairs because we're making the 0, so you need the ordered pairs. So we're going to say that we have 6, 0, and the second one is going to be 9, 0. And this is 0. Okay. B, find the zeros of the function. So you're saying again that y equals 0 because f of x equals y, and then y equals 0, and we have f of x equals 0. Okay, f of x equals x plus 1, x times x minus 9. So you have the possibility of 3 different zeros here. So let's go ahead and set this up. 0 equals x plus 1, x minus 9. This is all multiplication, so they can all be set equal to 0. 0 equals x plus 1. 0 equals x. 0 equals x minus 9. So now we're going to solve for x in each case. Minus 1, x equals negative 1. This is already solved, so we're done with that. Plus 9, x equals 9. So we're making ordered pairs. Just get the different color pen just so you can see it. So remember, this was the x and this is the y. So negative 1, 0. I know that this is a 0, so it's going to be 0, 0, because my y was 0. And then that's my x, so it's 9, my y is 0, 0. So you have 3 ordered pairs. That's your solution. Okay, find the roots. This is different. So find the roots of the factor polynomial g of x equals 0. So g of x equals 0, so let's rewrite this. Negative 1/2 x minus 2 to the third equals 0. So if we're going to talk about roots, you're saying that x equals some number. And that's what we're trying to find. So remember, if you're saying that g of x equals 0, you're saying that y equals 0. And you're also saying that g of x equals y. So right here, we need to solve for x. Let's divide both sides by -1/2. Then I have x minus 2 to the third equals 0. 1/2 goes into 0, 0 times. Now I need to take the cube root because I need to undo that cube exponent. Cube root of x minus 2, the cube root of 0 equals 0. X minus 2. So basically what happens is that those the cube root cancels out that cube. So we're going to say plus 2 plus 2, x equals 2. Okay, D, find the roots of the factor polynomial. So you're saying that x is going to equal something. That's what we're trying to find. You're saying that g of x equals 0, g of x equals y, and you're saying that y equals 0. So g of x equals 0. Let's set this up. X plus 3 cubed equals 0. We have to take the cube root to get rid of that 3 exponent. The cube root of x plus 3 equals a cube root of 0. So now you say x plus 3 equals 0, because remember that cube root went away. Now you're going to solve for x. Minus 3, x equals -3. I want the roots, so this is my solution. All right, find the zeros of the factor polynomial. You're saying that j of x equals 0, and I want to find the zeros. So these are going to be ordered pairs. J of x equals x minus 4 cubed times, this is multiplication, x minus, or x plus 9 squared. So j of x equals 0, j of x equals y, y equals 0. So 0 equals x minus 4 cubed times x plus 9 squared. We're going to split these up. 0 equals x minus 4 cubed. 0 equals x plus 9 squared. On the left-hand side, we're going to take the cube root of both sides to get rid of that cube. So then I get x minus 4 equals 0, plus 4 plus 4, x equals 4. Now on the right-hand side, I say that I have that perfect square, so I have to take the square root of both sides to get rid of that perfect square. 0 equals, let's see, x plus 9. I solve for x, minus 9 minus 9. X equals -9. So again, we said that we had y equals 0, x equals 4, and x equals -9. So here's your solution. your solution is going to be 4, 0, -9, 0. Because we're looking for ordered pairs. Okay, find the zeros of the function f of x equals 0. So f of x equals x times x minus 2 times x plus 5. So ordered pairs is what we're looking for. Like, you know, f of x equals 0, f of x equals y, so y equals 0. We're saying 0 equals x times x minus 2 times x plus 5. We're going to split this up. 0 equals x, 0 equals x minus 2, 0 equals x plus 5. So this one's done. Solve for x here. You're going to add 2 to both sides. X equals 2. Solve for x here. Minus 5 minus 5. X equals -5. So we're looking for ordered pairs. So this is your x and that's your y. 0, 0. 2, 0. -5, 0.